Okay, we are still working on solving algebraic equations. Uh, algebraic equations, and we're going to be solving addition. This today we've just given you some addition equations that have a pattern. Assume the following. In math, when we say assume, that's we're making something up. You can think of it. You can think of assume as taking the place of the word if. If this is true, if this happens, then what? So let's just take a look. Assume the following. A plus 1 is 2. B plus 10 is 20. C plus 100 is 200. D plus 1,000 is 2,000. We're asked to do these things over here. Solve the equation, solve each one. So we have 4 equations to solve. And then we're going to be asked to look at the patterns of the variables, and then we're going to be asked to look for the value of G. So the problem sort of helped us with our thinking with this ABC. So let's start with doing what it says, solve each equation. So I'm going to start with the A plus 1 equals 2. Remember, we're solving an algebraic equation. I want to know what is the only solution for A that makes that true. What is it? What does A need to be to make this true?
1.
1. If A is 1, then 1 plus 1 is 2, then that's true. So I can check it by substituting that back in. The other way, I can show my work if I wanted to do that. Remember, I want to know what A plus 1 more is. We'll take away 1 from each side. I'm just going to show it on this one. So on this side of the equation, I have A. If I subtract 1 on one side, I need to subtract 1 from the other side of the equation. So A is 1. All right. Sometimes you can just see what the answer is. What should B so that B plus 10 is 20? What's the only answer B can be?
10.
Okay. Once again, if I put the 10 in there, 10 plus 10 is 20. Or I can solve it similarly. What about C? Plus 100 is 200. What would C have to be to make that true?
100.
100. Okay. And then the next equation, D plus 1,000 is equal to 2,000. Instantly in math, just like in writing, if you see those 3 dots, it means the pattern just keeps continuing. D plus 1,000 is 2,000. What does D need to be?
1,000.
1,000. Okay. So now D is asking us, I'm going to switch colors. What patterns do you notice? So in order to look at the patterns, I just really want to take what the variables are and take a look at. So we're going to look at the patterns. So A is 1, B is 10, C is 100, D is 1,000. What are the patterns that you're noticing? So patterns, what are you noticing that's the same? Or how do you know that things are changing? What are you noticing?
Multiply by 10 each letter.
How could I write that? Well, let me write the words. Multiply by 10 each letter. So let's think of like a way to put that in math symbols.
Or you could also just add a 0 for each number.
I liked it better the way you said it the first time, Parker, by saying multiply by 10. And we know that when we're multiplying by 10, that's what adding the 0 is.
Actually, moving the decimal point 1 place to the right. I like that better than adding a 0. We're moving the decimal point 1 place to the right because it is a base 10 system. We can do that. Only on 10s.
Only on 10s, not on anything else. I liked when you used the word multiply because it's giving me some operation, right? So if I looked at these two, how are these two related? B, oh brother, right. B is A times 10, is that true? Is
B,
that another way of saying
B equals A times 10.
B is equal to A times 10? And then what would C be equal to? Equal to B times 10. Is that true? If I take 10 times 10, do I get 100? And D is equal to C times 10. So the letter before it times 10. Okay. So that's a pattern. Are there any other way we could say this? This is definitely what's happening. Each time the variable is a multiple of 10 more than the one before it. Is there another way I can write that? Not sure. Because we're trying to get over here to C. What would the value of G be if the pattern continued?
The value.
What would G equal to? G, what's the letter that comes before G? What's the letter that comes before G? G is
Hudson.
right?
Equals 100,000.
So you're thinking G would equal to 100,000?
No, G would equal 1,000,000.
Okay, G is equal to 1,000,000. Okay, I'm going to ask you to share your reasoning. How did you know that so fast?
Because D times 10 equals 10,000. So then F equals 10,000 times 10, which equals 100,000. And then G equals F times 10, which equals 1,000,000.
Wait, is E times 10, which is 100,000. Am I writing it right? And then E is F. Are you off the side? Can you not see?
Okay.
I just had something in the way.
F, do I have it right, Parker? Is this your
Yeah.
reason? Okay. I like that. Can we think of another way to write it? That works. I like it. It's a way to work. Sometimes in math, we look for another way. We're looking for that elegant way, that simpler way of saying it.
Can I put it in a chart?
What do you mean?
I don't know, like make a function table.
Ooh.
Or you could count out how many numbers you're going to have and then just add that many zeros.
Okay. Count out numbers. What do you mean by count numbers?
So count out each letter like A, B, C, D, E, F, G in that 6 letters. And then for every letter, you just add a 0.
1 0 for every letter? Or
Yeah.
multiple of 10? But does that work? Because A has 1 letter, but it doesn't have any zeros. And if we're thinking about 1 0, we're thinking about 1 multiple of 10.
Right, so
A, B, C, D, E, F, G. G is the 7th letter. It's the 7th letter of the alphabet, but it has.
right, but it's only, so it's 1, and then you just add all of the zeros until G.
Is that answer right?
Well, however, but G is the 7th letter. If you do that, then if I would have 7 zeros and not 6. Right? So I have to take away 1 of those zeros, right? Because A starts with no 0.
Right.
So B. So if I count the letter order, so G is the 7th letter.
But A is where you get the 1.
Right, I'm just trying to find a pattern from here. So if I knew, for example, and I don't know, that Z is the 26th letter, how many zeros would be after the letter Z?
26 or 25.
25. So I want to count the letter, I want to use the letter order, and there's a 0 for each one of those, take away 1. So I have to take away 1 from the letter order, count the letter order, and then -1, and that's the number of zeros. And the reason the number of zeros is the number of times tens, right?
Could I just do it another way?
Yes, I'm finding another pattern myself. What's another way? I like the tens. What's another way of saying what's with the 10?
Zéro. Zéro.
Were you sharing your way, Mrs. Nelson? Did I miss you?
I'm just putting it on Post-it to see if somebody else would take an idea with it and try it.
Okay, so I'm going to think about this a little bit. Let's zoom in on these tens.
Can you see me? Can you see my thing?
I can't see you unless I go, I just see me, I'm big.
Oh, I'm sorry. I'm giving a hint to everybody else.
Can you guys all see?
So what I did was I tried to make like a table and I put all the letters going down. So I have like A, B, C, D going down. And then I put tens in the other column.
Am I doing what you have there, Mrs.
Yeah,
Nelson?
you're doing exactly what I have there. And then I put tens. I actually made it all tens.
You made it all tens.
Yes.
Okay, but C is not 10. T is, what did you use? Oh, you put a 10. You put all tens here.
Yep.
You were going where I was going, Mrs. Nelson.
And exponents.
Ah, what exponent would this be? Or be? Who
When-
said it?
When you
Uh,
elegant, I thought of exponents in our letter of the day, E. E, exponents, elegant. And I thought, look at this. I think it works.
What could I put for B? B we know is 10. What exponent is here?
put 10 with an exponent of 1.
Right? 10 to the first power is 10. What would C be? C is 100. What's another way of writing 100 with 10 as exponents?
2.
10 to the second power. Okay, so what about D? 10 to the
Third power.
third power. What about E?
10 to the 4th power.
The fourth power. And then what about A? A is 1.
10 to the 0 power.
Anything to the 0 power is
1.
So now if I know the letter, so if I know the letter, I know the letter order number, the letter order, and I take away 1, that's the exponent. So I would put 10 to the letter order minus 1. So A is the first letter. I take away 1, it would be 10 to the 0 power. And later on in math, there'll be a fancier way to show it. I'm going to tell you, there'll be some fancier way to write it, but for right now, we can just simply write it like this. We're going to raise 10.
I want to know the fancier way.
If I could remember it, Mrs. Nelson, I would do it.
Oh, okay. Well, what can we can try to figure it out. So that can be my wondering. I wonder what the more elegant way would be. It's probably something like 26 minus 1.
It could be just whatever, but it has to be like you have to be able to put in whatever the letter order is. And so I don't know, but there's
Letter order minus 1. That's interesting.
adding up all of the values. It's like the summation symbol. There's some different ones. I can't think of a different way to do it.
Well, I'm never going to know because I'm never taking that math, I can assure you. I stopped after algebra 2.
But for right now we have a way. You tell me whatever letter it is. If I know what order it is in the alphabet, if I know it's the 15th letter, I take 15 minus 1. It's 10 to the 14th power. That would be my answer.
Because we know that in exponents, it's that, you're moving the decimal place from the 1, 2 places, 3 places, 4 places, you're moving that decimal point. Some people might tell you that you're adding zeros. Mrs. Nelson would tell you, you are moving the decimal point. You are changing the base value because you are multiplying by 10.
Good job, guys. This was a really hard one, and that's why it was that harder order, that higher order thinking.
The numbers look easy, but the thinking makes it interesting.
Yeah, definitely.
Anybody wondering anything else?
other questions we can answer? This was just a problem we liked the thinking on. Was there anything else you ran across you're wondering?
Were there any more difficult problems yesterday that you guys couldn't do in the math? I know the math is getting really hard. Here's how I know. People aren't doing it. It's hard to do by yourself. So this is the time to ask some questions and see if there's something on there that you would like help with. Think about it.
This is your opportunity for help, and we're right here.
All right, you guys, this is the way we think and have number talks. And this was a lesson about looking for patterns in math. And don't ever forget that clock trick. It's a great party trick.